Hey guys, it's Off51 here, and today we're going to be solving search in rotated sorted array. Before getting into this problem, I want to say that if you haven't solved this problem here, I recommend doing so. I'll leave a link in the description because in this problem we go over a very similar solution. Here we're given an integer array nums that is sorted in descending order with all distinct values. And in this problem we're also going to have a rotation similar to the last problem, which is why I said that it's useful to know that one. And basically what a rotation is moving this first index k amount of times to the right. So if our k is equal to 1, our 0 would be here, our 1 would be here, and our 2 would be here, and so on. So after we're given the array, they want us to find a target, and they want us to return an index of the target if it exists, and if not, we just return a -1. And they also want us to write an algorithm that runs in O log n time. So just looking through the array won't work because that will take O of n time. In the previous problem, we went over a solution that ran in O log n time by having a middle pointer, a right pointer, and a left pointer. And what we want to do here is check if our mid is equal to our target. And if it is, we just return the index. So let's just say the index is m. Otherwise, what we want to do is check where this 2 lands. Does it land on this half of the array or this half of the array? Well, we can see that 4 is greater than 2, so it wouldn't make sense for the 2 to be there because it's sorted in order. But 2 is less than 3, so we know that this is the half of the array that we care about. And also, we don't even need this 1 anymore because we know that it is not equal to it. So we can eliminate this whole part of the array. And now our left pointer is going to be here, and our mid pointer is also going to be there as well. And now we check, is m equal to t? And yes. So now we just return m. So what did we learn from this problem? We learned that if the right pointer is pointing to a value that is greater than our target, then what we want to do is update our left pointer to be equal to m plus 1. But let's see if there's any other checks. So what if our target is going to be equal to the actual right pointer? Well, we can see that this condition should still stand. So what we're going to do here, just modify this to less than or equal to t. Now that we have that condition settled, let's just see if changing the target would give us some different conditions. So instead of looking for 3, let's look for 5. So again, we're going to set up our mid pointer, our right pointer, and our left pointer. So is m equal to t? No. So now we just check. If the right pointer is pointing to a number that is greater than or equal to t, then we move our left pointer. And we can see that is not the case because 3 is less than 5. So now we just want to check the opposite condition. If left pointer is less than or equal to t, then we want to update our right pointer to be m minus 1. So now we don't care about this half of the array, and our right pointer is going to be here, and our mid pointer is going to be where the left pointer is as well. And then from here we can just check these conditions. Is m equal to t? No. Is the right greater than or equal to t? Yes. So now we just want to update our left pointer to be where the right pointer is. And at this point our loop will stop executing because we would be checking while L is less than or equal to R. So I cleaned up our pseudocode here. So now let's check to see if this code stands for another array. So we're going to start by setting our pointers up. So our left would be here, our mid would be here, and our right pointer would be here. And our target is 0. So let's start. Is mid equal to t? No, because that's 7. So now we just want to check the other conditions. If the right pointer is greater than or equal to t, then we shift our left pointer to be equal to mid plus 1. And we can see that right is 2 and our t is 0, so that is true. So now we're going to basically eliminate this whole part of the array and update our left pointer here. And our new mid pointer would be here. So now let's try it again. Is mid equal to t? No. So now we just check. Is our right pointer greater than or equal to t? And it is, but that's not what we want, as we'll see here, because now we're going to update our left pointer to be equal to mid plus 1 and eliminate this part of the array, which contains our target, and we would return a -1, meaning we did not find it. So how do we fix this problem? We can see that if this condition was just met, then we would have been able to update our right pointer to mid -1, which would have been here, and then our mid pointer would also be here, and that's exactly where our target is. So can we just switch these two conditions to avoid that? Well, no, because that wouldn't work. The problem would just appear on the other side of the array. So for this problem, the first iteration we wanted to execute this, and the second iteration we wanted to execute this. So what relationship can we see here? Well, for the first one, we see that m is greater than our left side, and same thing here. So maybe we can check if L is less than M, then we want to do this check first, and then this check second. So the code would look something like this. So this is the code. I added this equal sign as well because the L and M could be the same. So just taking care of that edge case already. And then now we perform this algorithm on this, it would work. But also we need an else statement here, just in case that condition is not met. And it's basically going to look the same as this, except instead we're going to check if the right is greater than or equal to t. And then we just do the same thing we did above. So to summarize, we want to use this part of the algorithm whenever we want to check if left is less than or equal to t, and then we want to use this part of the algorithm if we want to check if right is greater than or equal to t first. I know this can seem a bit confusing since the code looks basically the same on both ends, but it really does matter which condition you check first. So I'm just going to rewrite the code here so it's a little neater, and then we can go over the one final edge case. So now let's go through our last edge case. So I've already set up the pointers here just to save time, so now let's go through the code. So if mid is greater than or equal to L, it is. We want to check if left is less than or equal to t, which it is because 1 is less than 3, and we want to update our right pointer to be m-1, so it would look like this. And we can already see that this is wrong because our target is over here. So how do we fix that? Well, we can think about this problem like a number line. So let's just draw one out here and let's plot these points. And then now if we do our check, we see that 3 is not going to be in this number line here. So we can add a check to see if our target is less than our mid, because that way we know that it would be between these sets of numbers. Otherwise we want to move our left pointer up because it's going to be in the other half of the array. And then we also want to do the same thing down here, except now we're going to check if our target is greater than the mid, because then at this point it would mean that our array is sorted correctly in the second half, and we want to check if it's between the midpoint and the end point. So now that we've gone through all these cases, let's get into the code. To start, we want to initialize our left and right pointers. So left is 0 and right is going to be at the end of the array. And now we want to iterate through the array. So while left is greater or less than or equal to the right, we want to calculate our midpoint, and the way we do that is by using this weird formula here. And the reason I'm using it is because this prevents overflow, and if you don't know what I'm talking about, you can just Google it or watch my last video. But this is basically how we calculate the midpoint. And then from here is when we do our checks. So if nums at mid is equal to our target, then we just want to return mid because that would be the index. Otherwise, we want to do the checks we discussed in the examples. So if nums at left is less than or equal to nums at mid, then what we want to do is check if nums at left is less than or equal to our target, and if our target is less than our midpoint, then we want to update the right pointer to be at mid -1, and it is supposed to say right. Otherwise, we update our left pointer to be mid plus 1. And then now we do our else statement. And it's pretty much going to look the same as this, except it's just a little different. So I'm going to copy and paste it. And now we're checking if nums at right is greater than or equal to our target, and if target is greater than our mid. And then we just switch these two conditions. So here we will update our left pointer, and here we update our right pointer. And that should be it. After that, if we exit this loop, that means we didn't find the actual target, and we just return -1. So now we can submit the code and see if it works. So as you can see, this is a very efficient solution. So now I'm going to go through the code manually. So let's see how this code works. First, we want to initialize our left and right pointer to be 0 and 4 for this example, because the length of nums is 5. And I've already done that here, and I put the pointers pointing to the right spots. So now we check if left is less than or equal to right, which it is. We want to calculate our midpoint, which for this example, it's currently 2. So let's just do that. And now we check, is nums at mid equal to our target? Our target is 4, and our midpoint is pointing to 3, so no. And let's check, if nums at left is less than or equal to mid, which it is, because nums at left is 1, and nums at mid is 3. So if nums at left is less than or equal to our target, and 1 is less than or equal to 4, so that's true, and target is less than mid. So is target less than our mid? No. So now we want to update our left pointer to be mid plus 1. So this is our new left pointer. We no longer care about this part of the array. And then this is updated to 3. So now let's go to the next iteration. If left is less than or equal to right, we do this loop, which it is. And our midpoint is going to be 3. So we want to update this to 3. And now we check. If nums at mid is equal to our target, we return the mid. And our target is 4, and our mid is pointing to 4, so that's true. So now we just return m. If this video helped you in any way, please leave a like and subscribe. Thanks for watching, and I'll see you in the next video.